Hello, my name is Sofia Zapata, and today we will be doing project 3 of electromechanical systems. We will be dealing with transistors and logic gates. So to begin with, we should probably explain what a transistor, basic characteristics of a transistor. So a transistor is basically two diodes together. It looks like this, and it has 3 prongs. Usually they're labeled, but in this case, we would be looking at it towards the flat side, looking away from you, and that would make it our connector, our base, and our emitter. They're usually labeled CBE. The transistors work like a water faucet. Essentially, you need an input and output, and then a way to regulate the water flow. So in this case, our connector would be our in, our emitter would be our out, and our base would be our way of controlling the current in our circuit. So to begin with, we will be doing an AND logic, which basically means if one device is working and the other device is working, then our last device is working. In this case, we will be using two transistors. We're saying and. If both transistors work, then our LED will light up. If one of them doesn't work, the LED won't light up. And that's how we will change it. For this project, we will need some jumper cables, our Arduino, our battery, and of course our connector. Or you could use a USB and then just plug it into any outlet for power. Breadboard, 2 transistors, 1 kilo ohm resistor, and an LED of color of your choice. So to begin with, we should probably draw a basic schematic of it, and this is what it would look like. So as you can see, from our 5 volts, the current will flow, go towards the 1 kilo ohm resistor. Our transistor will receive it through the connector, and keep flowing towards the other connector, and it would be our emitter. So our emitter would send it to the other transistor, and then from there, since it's all connected, our base regulates it by letting it through. If everything is connected, of course, and in this case we will be saying that if it is connected, we will have a switch on and off. That would make our LED light up, and then of course it would just go back to ground. So for this, let's begin with just setting up our basic components. So let's just you can put it anywhere on the breadboard. Just make sure the flat side is facing away from you, so that it is brightly polarized. Sorry. So we're just gonna place it somewhere on the breadboard. Right now, it doesn't really matter. And place both of them. We're gonna place our 1 kilo ohm resistor. And we're going to place one of its prongs towards the connector of our first transistor. And the other side to our positive. There we go. Our LED, once again, just anywhere on the breadboard is fine. Just keep a note of which side is the smaller one. That will be our ground. That will be where we will be receiving our current. Right now that we have our basic components set up, we can start connecting them together. So to begin with, we will need one jumper cable from the emitter of our first transistor to the connector of our second transistor. This is what will make it an AND gate. They're both connected towards each other. And then another jumper cable for the emitter for our second transistor to the positive polarized side of our LED. Next, we can start thinking about, we can start getting some smaller cables. These cables will be our switches. This will connect our base to our connectors of the transistors. So one to its base, one to its connector, and then another one towards its connector and towards its base. Also, the way we set it up, our LED, we will need to ground it. So the shorter side, we will connect it to our ground. And then we will need two more jumper cables. One of them we will connect to our 5 volts in our Arduino, and the other one to ground. And of course, assign them to the proper spots in your kit, in your breadboard, sorry. Once we can start plugging them in. And then once we have everything set up on our breadboard, it should look something like this. For now, I'm gonna turn off my LED, and I'll tell you why in a second. I'll tell you how I did it in a second, but it's just so you can see it better on the video. So this is how our basic circuit should look. Okay, now, if you remember, I said that the two shorter cables that were connecting base to connector, and on both transistors, we did it for both, those will be our switches. So as you can see, it would be this blue one and this red one. So the AND logic of this design comes in these switches. So as you can see, if I unplug one of the switches, our LED turns off. If I unplug the other one, LED turns off. This is once again because of that AND logic design we have. If one of them is off, the LED just won't light up. Both of them need to be lit up. It's an AND logic. So if AND, both of our ways of current flow are on, then the LED is on. All right, and now for our OR logic. So we will make a basic diagram. As you can see, our transistors are now in parallel. This is because our gate logic is now for OR. So basically, this works as, sorry about that. This works in a way where it's either or. So if one of the switches is on for this transistor, the LED will turn on. If one of the switches for this transistor is on, the LED will turn off. If none of them are on, then the LED won't turn off. Just that way. It's either or now. So we can choose. So it's the basic, we will go back to our basic beginning of our design. So now, just the beginning, 2 transistors, LEDs, our resistor, and our source of the voltage. But now we're going to switch the cables. So we're going to switch the way the connections are made, essentially. So now we're going to grab one of our cables. Would be a good size. Let's do this one. And from our first transistor, we're gonna connect the emitter to the LED, the positive side of the LED. And then we're gonna do the same for our second transistor, emitter to the other basic side of the LED, the positive side of the LED. Once again, we need to ground the LED because we didn't have it set up directly into ground, so we're just going to connect it to ground. And once again, we will use the short cables to make switches. So our first one, connector to base. Connector to base. And the second one the same. Second transistor the same. Connector to base. So this is how ours will look. I'm gonna turn it off once again just so you can see the basic setup. And then I'll explain why. So as you can see, basically all we changed is our emitters are now connected to directly to the positive side of the LED. So as you can see, for now it's lit up, but if we disconnect, let's do the second transistor. Should be this one right here. Let's unplug it. Let's turn off the switch. Oh, it's still on. How did that happen? Let's see. Let's do the second one. Well, the first transistor in this case. Boom. All right. So you can see it just keeps. Oh, there we go. I had some. The cables are touching each other a bit. There we go. But as you can see, the LED will keep itself on as long, because we have an OR logic. The transistors are not in parallel, so no matter which one I plug off, it will keep turning on, no matter what. So this one off, still on, stuff like that. But what would happen if we plug both of them off? Completely off. So this OR logic is either or. Either we have one and the LED is on, we have both, the LED is on, or we have none and the LED is off. And that's our basic display of it right here. So once again, just to make sure, first switch off, still on. Second switch off, there we go, it's still on. And that's how kind of the logic works. Just to restate the logic here as our final design. The switches are off at the moment, and then we can just plug it back into the LED. So one of them comes off, still on. Plug it back in. The other one comes off, still on. Both of them come off. LED's off. That's our OR gate. Lastly, we have our NOT gate, which I guess the best analogy I could use is the one Professor Khan gave us for class. It's the bad marriage gate. If one person says yes, the other person's going to say no, and it would just be a constant argument. So basically, one thing is intended for a purpose, and then the other thing will do the opposite intended purpose. So for this case, we will actually only need one transistor, and our schematic of it will be our 5 volts goes through our 1 kilo ohm, and then from here, if the switch is on, it will flow through towards our transistor, which is the path of least resistance, but the LED won't be on. Now if we take off the switch, if we turn it off, the LED will be on, that would be one says no, the other one says yes. That's kind of the logic between it. So for this basic one, once again, only one transistor is needed, and then our LED. So the way we would do this is we will get one of our cables, once again, basic setup again. Nothing has changed except I took one of the transistors off. So our base and connection will be together. That will make our switch. Sorry. And our emitter would go directly towards ground. Then once again, we will connect our LED to ground. And since nothing is going towards our positive side of the LED, we need some way to power it. So that's we will need another cable from the resistor to our positive side of the LED so we can power it. So as you can see, our LED is off. The NOT logic is not allowing for the LED to be on. The current is not flowing towards that way. It's flowing towards the path of the resistance, which will be our transistor. But if our switch is... Sorry, I unplugged the wrong one. But if our switch is off, our LED turns on. So once again, switch on, LED is off. Switch off, LED on. So okay, basic understanding of it through the use of transistors. Thank you for watching. Any other further queries will be answered in the report. Thank you.